How the universe works. This is page 1, and you have this PDF. It should be on the web page, and that's web, not www, web dot, of course you're at the web page, but web.mac.com/d-askey-emac, D-A-S-K-E-Y-M-A-C. So if you go there and you click on physics equations, you'll get to this PDFs. So I only got 2 PDFs up right now, and they'll end up being around 50 by the time the year's over. But this is introduction, and we start off with you can't talk the language of physics without understanding the units we use, and we use metrics mostly. Now I'll go English too. The Air Force uses English. A lot of American companies still use English. So we'll go back between gallons and between feet and meters, and between gallons and liters and all those kind of things. But we're going to concentrate on SI units, which is System International. So all this stuff's explained on these pages. A lot of this is just background information in the red. Anything you see on these pages in red is historical. And I'm not saying you'll never see it on a test. You might see it. If you do see it on a test, I would cue you in. I would never expect you to know all that. That's done. It's just sort of background information. But if you do see it, it would be either bonus, or it would be, I would cue you in to, okay, make sure you know what, on the review sheet, make sure you know what happened in 1790 with Thomas Jefferson. But the tests are pretty much physics. So, but we bring in the history because you can't get away from history when you're talking physics or any kind of science. Anyway, read this, scan this over. A lot of this stuff, I'll be honest, I pull from the internet. Some of the stuff I write myself, of course, or I edit it. So you might be able to find this on Wikipedia. It's one of my sources. Sometimes I just go and look for Google search things, and this popped up. I've changed some things. I took away some dates I thought were kind of boring, and so I edited out all that dumb stuff, not the dumb stuff, but the trivial stuff, and kept what I thought were the important dates. Just for your own information, in case you're wondering why we use metrics. Don't miss these things. What you don't want to do is end up on a test and having not really looked at the equation sheet. You're not going to get, like I've done in the past, I'm going to stop doing this. I used to give them the equation sheets on a test. Now you'll get an equation sheet, but it's going to be a condensed version. It's not going to have all the explanation. For one thing, the school can't afford to keep printing these out. If we have 50 sheets, and 100 students, we're looking at 5,000 sheets, and I can't keep doing that. And that would also take up 50 sheets of our notebook. We only got 96. So it got to be out of hand last year. So what we're going to do is I'm going to condense it down. I'll take out all the examples. You're not going to have examples to refer to on a test. You'll have the equation, and you might even maybe have the derivation, unless that's part of the test. But you'll have the equations to refer to and a short explanation. But you're going to get a pared down version to use on a test. All right? So that frees me up, though, because I used to always, when I was writing these things, I didn't want to give away too much because I knew they'd get them on a test. And so now I'm free to write, explain everything I can, be as detailed as I want to be on these, and then because I know I'll always have a more abbreviated version for a test. All right, going on and on. But the point is that don't forget to look at every page, because it'll be a reference. I'm cool with you printing out. These are all color PDFs, and if you want to, send them to Sooner Copies or something, or your copy with Kinko's, whatever you want to go to. And they will digitally. They have a digital copy. In fact, Sooner Copies, if you're in Norman, now if you're somewhere else in the country, wherever you're going. But I know that Sooner Copies, Phil and Lee down there, buddies of mine, they will have a digital copy of every one of these pages in color eventually. They've got the first 2 now, and as I get them, I've got the first 35 done, but I want to go back and look at them again. I will send them to them, and they will have it. So if you want to go down and say, hey, Phil, could you print me out, or could you copy off for me, they'll do it for whatever the cost is, 35 cents a page or something. And that's probably the fastest, cheapest way to do it. And it gives them business. So anyway, the point is, this is kind of your textbook, because we don't have a textbook in class. So what I've done is, I've taken the first 35 pages and I put them in a notebook, just a small 3-ring binder in page protectors, and I refer to it to make sure, let's see, did I tell them that, or I'm going to edit it to change it next year, make it better. As long as I teach, you'll be able to go to my website, keeping in mind that these will change every year. This is a living, breathing thing here. It changes as I get better, or I find a better way of explaining something. This year it'll end up being 50 pages. Next year it might end up being 75 pages. Okay? Eventually be 100, and then that'll just be mechanics, and then I'll move on to electromagnetics, and that'll eventually be 100 pages. And then I'll go to modern physics, I'll go to relativity, I'll go to Einstein, I'll do special topics. But this is assuming I, continue to work on this for the next 20 years. So anyway, point is, next year, year after, finally you take physics, you go off and join the Marines, and you come back, and in 4 years, and now you're taking physics. Go back to my website, and you'll find or email me, and I can give you an updated version. All right. So here's basic conversions you can use on your homework. That's why I mean it's a good thing. Even if you print out in black and white, it's good to have around. All right. So there's really no examples on page 1. Now we get to page 2, and like I say, I pull these images off the internet. Sometimes I take pictures from class. Metric system is stupid. Stop jamming it down our throats! Who gets that upset about the metric system? Ah! Must have been written by a 9th grader or something. But anyway, it's not stupid. It's actually very smart, very organized. The English system, that's stupid, but it's historical. I mean, how we figured out what a foot and a yard is dumb. But that's what we're used to. So anything new, and it's not new at all, but since the French Revolution, we've known about it, and Thomas Jefferson talked about it. But anyway, these are all the countries that use metric system, all the ones in green, and the ones in gray, which is basically ours, and a couple of others still use Antarctica. Antarctica still uses the English system. Those 17 people on Antarctica. Actually, they're mostly scientists down there, so they use the metric system as well. All right, I'll keep yammering. All right, so now this talks about a little bit more kind of historical stuff, MKS versus CGS. We use the MKS system in here, and most physicists do. Now, MKS stands for meters, kilograms, seconds. And those are our basic units, all right? Meters for length, kilograms for mass, seconds for time. Other systems like astronomy, a lot of astronomers still, which is weird, but astronomers still use a CGS system, centimeters, grams, seconds. So we use the basic, most people use MKS, and that talks about that. All right, so this talks about all the basic kind of units we would use in here. Ampere, when we're talking about current. It's really not degree Kelvin, and I talked about that down here. They just changed it to Kelvin in 1967. They stopped saying degree, I guess. I don't know why. But they switched it to just plain Kelvin. And candela, we don't talk a lot about light, about that way of measuring light, but they're adopted as basic units. All right. Now we get to the metric system that we need to know. And there's prefixes go, there's yacto, and peta, and it goes on and on and on. It gets real small, real big. But I figured this scale is about right. We're going to go to a trillionth of a meter. Now when you're in the picometer range, you are inside. You're in atoms. You're like we're talking about diameters of atoms here. So that's small enough for us. We don't need to get down to the quark level. And then terameters. Terameters is 1 trillion meters. And you can talk some astronomical distances. When we get to a little astronomy, we'll talk about astronomical units. We'll talk, of course, about light years, light minutes, that kind of thing. So really, using astronomy, using distances in terms of light, speed of light, is the most appropriate for long distances. Or astronomical units, which is the distance from the sun to the earth, in the solar system kind of units. But terameters will work as well when you're talking about distance from, Earth to the moon. Of course, we're not that far, not terameters, but when you're out, Earth to the sun, or Earth to Jupiter or something. So we use those big units sometimes. Okay, now we're going to play the metric game, and that's simply, it's a little game that I came up with, and it's just a way, basically it's a way to get you to remember your units. Now, I'm pointing above me, and if you're in my classroom, you know what I'm pointing to. It's the same thing as this. I have, similar to this, I have colored version hanging from the ceiling. And so I'll try not to be so specific to my classroom, because I want students all over the country, if they're just happen upon this website, to benefit here. So I'll try and be more general, but okay. So, and I'm not going to be specific to this year. I mean, right now it's 2009, but hopefully students will be watching this, in 2015 and 2020. So if I say, well, Billy over here, Billy and Willis and Cooper do a lab. Well, then, you guys know what I'm talking about, 2009, but they won't know who I'm talking about. So I'll try and keep it general. All right, now we go to the metric.